Hi everyone. Today we're going to finish up decision making. We're going to see an example of how to use a probability distribution, so how to use the binomial probability to make the decision, and then also how to use expected value to make the decision. So sometimes we can use simple probability, sometimes expected value, sometimes probability distribution, depending on what we're looking for. So in our first problem, okay, an airport shuttle company takes 8 reservations for each trip because 25% of their reservations don't show up. Is this a reasonable policy? The airport shuttle only has capacity to take 6 passengers. So obviously, if all 8 people show up, we got a problem. Also, if 7 people show up, we have a problem. So that's the first thing we got to do. Okay, we have a problem if 7 or 8 people show up. So we have to find the probability that 7 people will show up and the probability that 8 people will show up. And this is binomial because they're either going to show up or they won't. So two options, success or failure. And we'll assume that each person is independent just to make the calculations more manageable. So for 7 people to show up, we have 8 total trials, and we're going to choose 7. We want exactly 7 people to show up. Now it says there's a 25% chance that they don't show up, which means that there's a 75% chance they do show up. So this is the formula to find out the probability that exactly 7 people show up. So that's a 26.7% chance that exactly 7 people show up. Now we're going to do the same thing for 8 people. So we're going to have 8 choose 8 because we want exactly 8 people to show up. Okay, we want 8 people to show up, and we want 0 people not to show up. And that's a probability of 10%. To find the probability that more than 6 people show up, so either 7 or 8, we add them, and we get 36.7% chance. Now, if I was running a company, I would say this policy is a problem because 36.7% of the time I'm going to fail. I'm going to have too many people. I can't take them to the airport. I'm going to get bad reviews. So, as the company, they'd probably make the decision maybe just to have 7 people. They only have a problem 26% of the time, depending on what they're willing to accommodate or willing to do. But this tells us 36.7% of the time we have a problem, and then we have to make a decision based off that information. Now, technology companies also have similar issues where they have to decide between different models and different products. So in this case, they have a model Tab 5000 and a model Tab 5001. Okay, these are 2 different tablets. Which one should they produce? So the Tab 5001 costs more to produce, so it's going to have slightly less profit, but it also fails less. Tab 5000 fails more, but it's got a higher profit. Higher profit, lower replacement. So we got to figure out, using expected value, which one am I going to make more money in, or which one am I expected to make more money from? So let's figure out the expected value of each. So for the Tab 5000, it says 95% of the time we're going to be good, doesn't fail. So the profit is I make 150, it costs me $100 to produce it, so I have a net of $50. 5% of the time it's going to fail, and I'm going to lose money. So 5% of the time I make $50, I got to pay $100, and I got to pay $130 to replace it, so I lose money. My expected value is 95% of the time I get 50, 5% of the time I lose 80. Overall, each one I should expect $43.50 per unit. Now the Tab 5001, I'm going to do the same thing, except this time it's 99% of the time, and I only make $45 profit because the cost to produce is higher. 1% of the time, it's going to cost me even more money because the cost to produce is higher and the cost to replace is higher. So 1% of the time, I'm going to lose $90, which is more than the $80, but it's less percent of the time. So let's see the expected value. In this case, it's $43.65. So in this case, my expected value is higher. So if I was making a decision, okay, if I were the head of production, I would say let's make the tab 5001, because while we make less profit, if it doesn't break, and we have more liability if it does break, it's going to break less percent of the time, and therefore it's going to have a higher expected value. So 15 cents per unit when you're dealing with hundreds of thousands, if not millions of units, is really important, and that's how companies use probability to make decisions.